Alrighty, so today we're going to have a look at seasonal indices. So the way the seasonal index works, singular seasonal index, is that it's a way of comparing a particular part of a year to the whole average of the year. So there's a few ways you could do this, but no matter what, in the end, you'll need to work out the yearly average to do it. So let's look at the way we are going to be doing it. So to calculate a seasonal index, you take the value for that season and you divide it by the yearly average. And what we get is basically a percentage comparison, or a decimal comparison between the value and the yearly average. Alrighty, so let's have a go at doing it. Well, we've got some data here. It's been split up into 4 seasons, you can see. We have December to February, that'd be summer, then we've got autumn, winter, and spring. So we've got the 4 seasons. So to start off with, if we're going to be dividing by the yearly average, well, first we need to work out the yearly average. So to do that, we just add up all of the values and divide it by how many there are. Now, each of these seasons is going to get its own seasonal index. So we're actually going to calculate 4 seasonal index, 1 for each season. All right, so we can see that the yearly average is 600. So one way we could compare these two is by saying, well, 600 is bigger than, is less than March, May. In other ways, autumn, March, May, is 40, sales is 40 bigger than the yearly average. Or we could say September to November is 90 less than the yearly average. But that's not a very helpful comparison because it doesn't really get to the sense of a percentage. And often we want to deal with percentages because they're a little bit easy to compare. So let's work out the seasonal index, abbreviated to SI, from December to February. Well, all we do is we take the value, in this case 820, and we divide it by the average, which is 600. Now, since we're thinking like a percentage, we're going to round to 2 decimal places. So I'm getting 1.36666, and I'm going to round that to 366, so that'll be 37. Alright, so that's the seasonal index for December, February. What about the seasonal index for March to May? Well, that's going to be 640 divided by 600. Once again, we're going to round that to 2 decimal places, so 0.7. Now we can do the seasonal index for June to August, which is going to be 430 over 600, which rounded to decimal places will be 7.2, and then final one. So you can see it's just a bit of a straightforward calculation that we have to do for each of the seasons. So in this case, because we had 4 seasons, we've got to do the calculation 4 times. So there we go. Those are our 4 seasonal indices. Now, just for simplicity, we might just rewrite these in a table. Alrighty. So these are our 4 periods, and I can just copy down these seasonal indices. So there are my 4 seasonal indices. Now, let's actually just take a moment to read these. So one way of thinking of this one here would be like 137%, okay? And then the way to read that is that 100% is the average. So this one would be 37% above the average. So you can kind of see that it's a slightly more useful way because instead of comparing it just by a raw number, we can actually get it as a percentage of the average. So then we can read this one as 7% above the average. How do we read the ones that are below the average? Well, we can see that both of these are below. So then the question is, well, if this is 72%, how far away is it from 100%? Well, it's 28% below the average. And similarly, this one will be 15% below the average, because it takes 15% to get from 85% to 100. So that's how we actually use these seasonal indices as a comparison tool. We're going to see that they come up and have many, many other uses as well. But that is seasonal indices. See you in the next one. Bye.